Good morning, all. How is everyone doing? Okay, you can go ahead and begin. I hope you all had a good week and got a chance to go over the notes, if possible, going forward to see what's on ahead. So can proceed. Last week, Fiona left off on variables, but I wanted us to first um, take a detour from that. We look at strings, and then now we shall go back to variables once we've done strings, so that at least we cover the two basic data types of numbers and strings. So strings are anything alphabetical or numerical, so A to Z or 0 to 9 or any special characters. The only thing is that they have to appear within quotes. So you can either have single quotes, so single quote, which will give you a string, or you can have double quotes. Either of them is going to get you, is going to result in a string. And so both of them are permissible in Python. The only thing is that you have to be consistent in which one you use. If you are using single quotes, then use single quotes throughout. If you're using double, then use double throughout. The reason we have the two different types is that you might want to have a single quotes appearing in your string, in which case then you will have to encapsulate your entire string in double quotes. So for example, Eric's bag is red. That way, I have a single quote appearing on here, and so I have to have the double quotes at the end to make sure that that sentence is written out. If I was to use single quotes all through, Eric's bag is red, you notice immediately that after this second single quote, the rest of the text turns a different color. So we have black for the regular words and green for the reserved words. And if you run this, you'll get an error. And it's going to tell you that you have a syntax error, invalid syntax. It will point to the location where that error has occurred. In this case, it's showing that at S, it was expecting something different, but in this case, it has seen that I had my string and then I terminated it, And so it doesn't understand what comes after that. That is why you need to surround any single quotes in double quote. And likewise, if you have double quotes in your sentence, you use now single quotes. So this has a double in parentheses quote. So if I run that, I'll get my sentence out. But if I repeat the same and I use double quotes, you see again, the color after the second double quote turns black, which shows that I've terminated my double quote before. And likewise, if I run that, I will get an error, invalid syntax. I'm sure you must be asking, so what happens then when I have both single quotes and double quotes in my text? In that case, then we use escape characters. And these are characters that enable you to type special types of characters in your string that such that Python is notified that this is supposed to be a specific character and not punctuation or not anything else special in Python itself. And we'll come across other types of escape characters, but for purposes of strings, we'll just use the backslash to show you how you can escape or rather the backslash is what you use as the escape character to notify Python that this character is something that it is not usually used as in the program. So if we use backslash of, let's start with the single quote. So Eric's bag is red, single. But if I come and I escape this first quote with a backslash, you notice immediately the rest of the text turns red. So it's telling Python that this specific character is supposed to be treated as part of the string and not as the termination to the string. So if you run that, you get back your text as is. And so this way I can have this sentence has both double quotes, escape, double quote, and single quotes, escape, single. But since I can either use an escape character for the single or not, because it's already being enclosed within the double quotes, terminate my string and I run that. And you can see that now I have both single quotes and double quotes in my string. Any question on that?
That was a mile a minute, but yeah, just going through, just catching up.
Yeah. No, I'll leave it on here so that you can just look at it and then before we proceed.
Okay.
So just go through that. If you have any questions, try it out on your own.
Hi, Eric.
Yes.
Is there a space between the escape character and that quotation mark?
No. It's supposed to be one. Let me see, we can actually test it out just now. Yeah, it's supposed to be together. It's one unit. You can't have a space between them.
Okay. So in the output 8, is it meant to be the way it is?
So this sentence has both double quotes. So there's this one and single quotes, which is this one. Yes.
Yeah.
Because if I was to, but you see for this one, because the single quote is already, I get what you're asking about. Because of that, no, I need to remove that. No, it's still going to show. Let me see if I double escape it. I think it's the escape character shows because this sentence has both single quotes and double quotes. Let me me see. I think the output escapes it because it has already seen this first one. I'm not sure why. Let me just check on that.
Or it needs to be okay, just check it, because I was thinking maybe you need to add another quotation before
No, but you
single.
see, well, let me do this. Let me just add my, sorry, let me add my single quotation there. I see. No, it still escapes that. It's still escaping that. Let's reverse. Let's do
because,
instead of.
I'm thinking you have opening and closing for this sentence has both double quotes, then escape, then that, and single quotes. Then you only have the one that you're closing with.
For some reason, it looks like it's escaping and single quotes. Then if I escape a single quote, and I do that, it's escaping the single quote. But if I do up here on cell 7, if I skip the single quote, that backslash character doesn't appear. But at the bottom, the escape character is appearing, and I'm trying to figure out why that is.
Okay. Okay.
If I leave that out, I'll run into an error. Yeah, because I need to. If I do that, I have.
Yes.
Let me do print this. I'll also talk about something about why there's the quotes appearing in the output when you do that. But when you do print, you'll notice there'll be no quotes in place. So let me try now and escape a single quote. For some reason, when I use print, that escape character does not appear. So let me also do with a double quote and then escape the double quote. I see. For some reason, when I just call out the text on its own, it escapes that single quote, but when I print it out, it does not escape it. Edit, copy cell, edit, paste cell below. So let's do it without the print statement. I think it's just an artifact of, it might just be a bug in Python, because these two are exactly the same thing. But with the print statement, it does not print the escape character. Without the print statement, it prints the escape character. So I'm guessing it's probably just a bug.
My thinking is, can you try having the double quote at the end? Then we have the escape just before the single quote.
So yeah, this one has the double quotes at the ends.
Yes, but we do not have that backslash before the single quote.
We don't have it, and that's why I'm saying I'm thinking that it's probably a bug, because whether I have the backslash in front of the single quote or not, it appears in the output. So when I call the string directly, it returns the backslash. But when I print the string, when I use a print statement to print the string, it doesn't have the backslash in place. So I'm thinking it's probably a bug in how Python is handling this specific case.
Okay.
Yeah, it's only reading the first. It's only reading the first quote. Like it won't display the escape character in the first one, but when I remove the escape character in the first double quotes part, the other escape character disappears.
Let's see. But then now this becomes.
Yeah, I'll have to remove that the double quote as well. Like so that disappears. But
if you do that.
Yeah.
Yes. So for some reason, when you have, I think with a single quote, when you have an escape character anywhere within that, So like if I was to do n, which denotes a new string, a new line, no, that still doesn't appear. Let me see, what can I use as, give me a second.
Or does it mean that we can only use it once in a sentence?
If you're using it, if you have a single quote in place, so let's do this. Let me do that, and then I remove the single quote and I see what it does. If you have, yeah, clearly, if you have another single quote within the sentence that is encapsulated in double quotes, then the character, that slash character appears. But you notice when I remove the single quote, the slash character doesn't appear. So it must be a bug in how it handles the presence of a single quote in your string. Yeah, it must be a bug in Python, because when you call the string directly, it appears. But when you call the string as an argument in a print statement, that slash doesn't appear. So I'm thinking it's a bug. I'll make a note of checking out, and then I'll just report back on that later. But other than that, you understand the concepts of strings?
Yeah, sure.
Yeah, I think so.
Yeah. Any other questions on strings?
Eric.
Mm-hmm.
So in input 5, line 5.
Okay.
I see the input has single quote.
Mm-hmm.
And the output single quote.
Mm-hmm.
And in input 7,
Mm-hmm.
it has single quote, but the output has double quote. What's the difference?
Oh, okay. Get what you're saying. This is a double quote, single. Single. Let me add another cell. My guess it's probably because we escaped the single quote character, and so it's to differentiate. Let me see if I do Eric's bug is red. We see what we get. This has a double quote. It's to differentiate that I used, if I use single quotes, the output is going to show me in double quotes. If I use double quotes, no. I think it's because I have a mixture of of quotes within my string. I'm using an escape character.
Okay.
Let me do it without the escape character. Eric says double quote. If you have the presence of a double quote in your string, the output will have single quotes encapsulate it. If you have the presence of a single quote in your string encapsulated by double quotes, the output will have double quotes. So it's just to show that you used, so if your output is showing that it is encapsulated in double quotes, it's indicating that within your string, you used the opposite kind of quote. So in this case, you used the single quote. So you can see in line 30, I have single quotes outside, but I'm quoting double. So it's showing that I used a double quote inside, and so it encapsulates the output with single quotes. Though for all of them, if you print all of them, so print this. So if I print that, I missed my quote. You see, I don't have the quotes in place. Anytime you use print, you're not going to get the external quotes in place. So if you want to have a clean string without the quotes surrounding, then just print out your string. That's one way of doing it so that you don't get the quotes outside. But yeah, I think the difference is that it'll be single if you have a double within, and it'll be double if you have a single within.
Okay.
Okay.
Yeah.
Any other question? Okay, if not, we can now go ahead to variables. So Fiona had briefly mentioned on variables last week, the last part of the class, and that's what we are going to continue with that for now. Variables is basically, these are just labels that we use to identify different locations in memory so that it holds, we use it to point to that location in memory and whatever contents are being held in that location in memory. So that as you're coding, you don't have to try and keep remembering, there's this value I want to use in my computation, and I want to use it repeatedly. And so once you've come up with your software, with your program, and then you want to make a change, then you have to go to every single place where you've used that value and make the change there. Variables help us make the change only in one place, and it affects everything else in the rest of the code where that variable name has been used. And so you remember from last week when we were looking at the different numbers, I was using the X's and the Y's. So those are variables. And then I just needed to change the value of X, and then my calculation, run my calculation. And it will now do the calculation with the new values. So let's say X assign 2, Y assign 3. So if I do X plus Y, I get my value 5. So assume I'm using X and Y in different portions of my software. I don't have to go to each of them, and then change the value of X or change the value of Y. I can just come to the variable, change the value of the variable, rerun the computation, and it gives me the result with the newly defined variables. You remember from the presentation, we stated that Python is a dynamically typed language, which means that you don't have to specify the type of your variables when you're assigning the values to them. Unlike statically typed languages like C or C++ or Java, where before you use variables, you have to say what type of variable it is, and you can only use that data type for that variable. So for example, if it is numbers, then you'd have to say X is a number, and you can only use it for numbers. And now to an even deeper level, X is a number of type integer, and you can only assign integers to it. Y is of type float, and you can only assign type float to it. For characters, Z is of type character, and you can only assign characters to it. But for Python, what happens is that when you assign the variable, the interpreter looks at it and automatically decides that because this is a number that has been assigned to the variable X, then this is of type integer. If I was to do Y 3.0, then it will show automatically that Y is of type float. Then if you get type X, type is the function that you use to find out what kind of object a particular value is, or a particular variable is. So in this case, if we type X, we look for type X, it reports it as an integer. I'll just also do type Y on the same line. So X is reported as an integer, Y is reported as a float. If I was to have an additional Z and give that 2, and then run that, and then down here type Z. So here we have the three types. We have the integer, which is X. We have the float Y 3.0, and then we have Z string, which is 2. So that's what variables are. They just assign values to them, and these are pointers to memory. So this location in memory is holding a value of type integer. Y is pointing to a location in memory that is holding a value of type float. Z is a pointer to memory, labeled to a pointer in memory that's holding the value of a type string. Basically, that is what variables are. And you can also, beyond just holding single values, as Fiona had demonstrated, you can hold other data types as well, some of what we are going to look at later. You can have strings. I mean, you can have lists. So we can have my list. Let's just have a list of numbers. Then if I call my variable, I get back a list of the different items in it. But now this list has been assigned to this variable, my list. You can have my dictionary. And we look at all these data structures later. For now, I'm just using them as examples of what you can get in a variable. So let's call this A1, B2. Then if I call my dictionary, what did I have? Sorry. This is supposed to be that way. So I get back my dictionary. So basically these different data structures, just a label that points to a location in memory and says, in this location, assign this space to display a dictionary. For this one, it's saying, in this location, assign this space to display a list. That's what variables are. And for variables, any questions on that so far?
Hi, Eric. What is a dictionary?
We shall touch on that later. I'm just giving an example of variables. It's a data structure. It's a mapping data structure. We'll look at that later in the class. From now, I'm just using it as an example of the different kinds of items a variable can contain.
Okay.
Okay. Any other question? So variable names, let's look at the rules of variable names. So a variable name can contain only numbers, letters, and the underscore string. It cannot contain anything else. So and for numbers, variables can only start with letters and underscores. It cannot start with numbers, but it can contain numbers. So variable equals 1. So this is just a variable that is all alphabetical. Variable with underscore 2. Oh, then the other thing is that I need to mention, when you assign a variable, because you're doing an assignment, it's not going to return a result. That's why you noticed when I ran that cell, and if I run this cell, I don't have an output, because all I'm doing is just I'm telling the interpreter that just set aside this space in memory and assign it this value, but I'm not telling it to return the value. That's why you don't have any output. To see the output, you actually have to call the variable itself. So in this case, let's rerun cell 45, and you see I get my output 1 in place. So this is an example of a variable where it is just all letters. The second one is an example of a variable that has underscores in it. And the thing that Fiona had mentioned last week as well, if you have long variable names, you can start typing it out, press the tab key, and it's going to return a list of the different variables that have been defined. And you can now just select the one that you want and go ahead and run the cell. And then we'll have a variable that has numbers in it, variable with number 1, and we'll assign that to 3. and then we'll call it. So this is what is permitted. Either letters on their own, letters with underscores within them, letters with underscores and numbers within them. These are the only permissible types of variables that you can have. You cannot start a variable with a number. So one variable equals 4. This will give me an error. It will say invalid token. And that's because it's expecting, once you have a number, it's expecting that this is supposed to be a value that you're trying to call. But when you call it with something else next to it, it doesn't understand what that is. And that's why it gives this syntax error invalid token, and it points to the location where that error is. So here we tried to start a variable name with the number and we got an error. But so long as the number appears after either the alphabetical or the underscore, then it's fine. Actually, before we get to that error, let's start underscore variable starting with underscore. This is also permitted. Let's call that 4. And then let's go ahead and call our variable v. That is also permitted. So the only things permitted is letters on their own, letters with underscore and number after. The number has to appear after the letter or the underscore can also begin the variable name, and everything else follows. You can also do, again, similarly, underscore number equals 5, and then we just call underscore number. You see that is also permissible. So long as your variable names begins with a letter or an underscore, numbers can come after the fact. Numbers cannot come before anything else. That will result in an error. Any questions on that? Yes, I'm going to touch on that, Dan. So we've seen that variables start only with letters or underscore, but can contain numbers. You can't have special characters in your variable. So let's call variable, if say I want to have a dash, this will give me an error. Variable x equals 2, that'll give me an error. So the only, other than letters, the only characters permitted are underscores and numbers. So the next thing, in answer to Dan's question, variables are case sensitive. Or rather, Python is a case sensitive language. So let's have name is Eric, and then I call name. That's going to return the variable that the value that I've assigned to name. But if I was then to go ahead and call name, I get an error, and there is name is not defined. This is something that you're going to run into every so often. Anytime you're working on a project and it's showing and used a variable and it gives you this error that it's not defined, chances are you mixed up the cases. So name with a lowercase is different from name with an uppercase. So be very careful about that Python is case sensitive. If I do name, same thing, I get an error, it's not defined. So always make sure that you have your cases well defined, or rather well laid out. And as you're calling your variables, if you run into the it's not defined error, then check the cases of your variable names. Chances are you used an uppercase or a lowercase when you're not supposed to. Any questions on that? Okay. Yeah, so those are the rules of variable names. In terms of, you can actually have a variable name that is any length. So this is a very long variable that has very many words and numbers. 100, 239 in it. Assign that to 45. Then I go ahead and I call my variable name. So you can have any number of characters in your variable name. I mean, might not be permitted to do that in terms of legibility of your code and whatever, but the ability is there. If for whatever reason you need to have like a very long variable name, you can do that. You're not limited by the characters, so long as it starts with either a letter or an underscore, and doesn't have any other special characters or spaces in it. Any questions on that? So those are, let me just go back to, so those are the rules for variables. Now, besides rules, there are also variable conventions. And there are several conventions that are in use in Python, that are permitted in Python. There are 3 of them, and we'll just go over each of them one by one. The first one is, the first one is camel case notation. And camel case notation is where you have multiple words for your variable. The first word starts with a lowercase letter. All subsequent words start with an uppercase letter. Camel case notation. So if I have camel case variable and assign that to 2, then I call it. So that's the first one, where the first word begins with a lowercase letter, but all subsequent words begin with an uppercase letter. Then similar to it, we have Pascal case notation. And this one, all words are start with an uppercase letter. Camel case, remember the first word is lowercase, but everything else is uppercase. Pascal, all the words start with uppercase letters. So let's go ahead and do that. Pascal case notation. Let me do this variable 3 Pascal. Yeah. And then the final one is what you've seen me using. That is called snake case notation. And this is where all the words are lowercase, but then they're separated by an underscore. Snake case variable. Oh, sorry. Okay. So all the words are in lowercase, but then they're separated by an underscore. Those are the 3 different notations. Which notation you use is up to you, but whatever you pick it and be consistent with it. For me, I like the snake case notation because it's easier to read the words when they're separated by an underscore. Whereas for these others, it's harder to read the words that are not separated. Even if we have the initial letter of each word a different case, it's still harder to read than these others. That said, there are certain situations where you might want to use a specific kind of notation for your variables. You'll find that usually Pascal case notation might be used, say, for example, to define constants. If you have values in your code that don't change over the duration of running of your program, then you might want to go to Pascal case notation. Say you want to say speed of light is what, 300,000 square kilometers, so speed of light. Because this is a constant, it never changes in the running of your program, then you can use Pascal case notation to define it. That you might say that what camel case variable you might want to use that to define a different kind of variable that you use in your code as well. So it'll come down to look at the requirements of whatever project you're working on, and you find whether there are different kinds of objects that you want to define for your code, for your software, and you'll decide constants, I'll use this notation, maybe lists and whatever, I'll use this other kind of notation, and regular variables, I'll use snake case notation. That's entirely up to you. For a lot of what you're going to do for this course, we won't have that distinction over constants or any other thing. So for our case, we'll just use, there'll just be regular variables that change throughout the duration of the running of our code. And so we'll just stick to one notation. Like I said, my preference is snake case variable. So from now on, you won't see me using any of these others. I'll just stick to the snake case notation. Any questions on that? Then the last thing I'm going to touch on variables are keywords, which is actually should fall under the rules that the other rule concerning variables is that you cannot use keywords, and keywords are words that have been reserved by Python that mean special things. You've seen some of them like print. And a hint as to what a keyword is that it's going to turn green. Well, print is not a keyword, print is a function. So you have functions and keywords. So for functions, like for example, there's print, there's what? There's range, there's len. These are all functions. And these are functions that have been specially look at functions later. So this, anytime you type a word and it turns green, then you know that you're not supposed to use it as a variable. Keywords are different. Keywords mean something else. They don't, they are not functions. They're used, for example, to show something about your code or to do something to your code. And some of those keywords are words like, I'll just print a few, and then I'll show you how you can get like a list of them so that you know what they all are. So there's and, which we'll look at later. There's else, which we'll look at later. There's in, which we'll look at later. From. And see the difference between keywords and functions is that functions turn green, but are not bold. Keywords turn green and are bold. So print, len, range. You notice that these are all, just give me a second about that. Yeah, so what I was saying was that keywords will turn green and bold, but functions will turn green and just remain regular. They won't turn bold. That's how you know the difference between the two. To get what the different keywords are, just type help, which again turns green but not bold, showing you that it is a function with the parentheses, and then run that cell. Then whatever comes up in that box, you can use this to find help about anything in Python. In this case, we want to find out what the keywords are. So just type keywords and enter. And it returns this list for you. So these are the lists of all the keywords in Python. None of these can be used as a variable name. So that's how you find out what the keywords are. When you're done, you just type quit in the box and it's going to come out of that help box. And you've seen, you can also look for other things. So actually, let me rerun this. You can look for symbols. It'll show you what all the symbols in Python are. You can look for modules. Modules shows you just a list of the different, it's giving me a warning. Oh, it's still trying to run it. Yeah, still trying to run it. That might take a while, so let me just interrupt this. Remember from last time I showed you that if it's an asterisk, it means that that cell is still running. In this case, I'll just interrupt it and let it be. Let me see if it returned anything at the bottom. Yeah, and then it's showing that I gave it a keyboard interrupt when I stopped it manually itself. So let me just rerun this and do keywords and leave keywords on the screen. Yeah. So these are the different keywords in Python that you're not supposed to use. Going back to what Dan had asked earlier in terms of case sensitivity, so I have false as a keyword, but if I type false with a lowercase f, it doesn't turn green because these are two different words. And likewise, I have print, lowercase, print is fine. It turns green, not bold, showing me that it's a function. But if I use print with a capital P, it doesn't turn green because these are two different words. So yes, you can do this. However, it is not encouraged for you to do this because somebody who's reading your code might become confused, even if it is a legitimate variable. And I can actually go ahead, let me add a new cell. So false equals 3. Let me see, it's because I have, because it's still running. Let me stop this, quit, enter. Yes, so false equals 3. And then if I call false, I get back my variable on there. You see, you've seen that it's permissible. However, because you don't want to confuse people who are reading your code, this is not generally allowed. Keep away from using keywords, even if you change the case as variables. Just use other, there are very many other English words that you can use, or whatever language you're trying to work with. There are so many more than just these few that I'd advise you keep away from keywords or function names. So similarly, I can do print is equals to 3 and I call print, same thing. If I use a keyword as a variable name, so let's say and equals 3, immediately I get an error. Here I can't, Python will not allow me to use a keyword as a variable name at all. However, it will probably allow me to use, you see, it's allowed me to use the print function as a variable name. So if I call print, I get back 3. But now, the problem, what happens is that now if I try to do print 3, let me print 4454, you see, I get back an error. It's saying that int object is not callable. That's because I've assigned to the function name print, I've now, once I assign it to the variable 3, it now takes away from the function definition and makes it into a regular variable. So when I go back and try and use it as a function, as it was originally intended, because it's now something else, I get back this error. It's showing that it is not callable, and now I have a problem. Now I would have to redefine this function to use it in the way it was intended to be in the first place. That's why you're told not to use function name as variables. You've seen that for keywords, Python will not allow you to do that. Function names, Python will allow you to do that. But then now the consequences are, when you now try to reuse the function as it was supposed to, as it had been designed to, you run into this error that you can't now use it in place. Now for here, I'd have to, first of all, delete this. Let me delete this. Because now this has been locked into memory, I have now to restart my kernel. So remember last week I'd shown you the different ways you can do that. In this case, I'll just use these double arrows. So I'll just restart and run all cells. It's going to stop wherever there's an error. So in this case, my first error appears where? Down here because of this. But I'll go ahead and go to the bottom. And if I rerun this, now you see I'm able to print the number. That's why it's highly advised, keep away from function names as variable names. And even if you can change the case, don't do it. Just use other words. There are millions more words you can use for variables. And when you look at the different combinations together with the underscores and everything, billions more variable names that you can use. Any questions on variables?
And not really about the variables. Just wanted to remind myself about the comments. I remember we were using the hashtag to create comments, one-line comments, right? Single-line comments.
Yes.
How about
Yes.
multiple lines?
Multiple line, you just have to do the repeated hash. This okay. you can do. Yeah, for Python, you just have to do the repeated hash. There's a way you can do a multiple line comments, but that comes during function definition, and I'll explain that when we get to functions. But if it's regular code, let me see. You can do this. You can actually have triple strings, triple quotes to indicate strings as well, not just double quotes. But this is a special case. This one is used when you're doing, when you're documenting a function, and I'll talk about that. It's something called doc strings, documentation string. So if I do, Eric is here, he is teaching, this class is good. So I can run that. You've seen the output has shown me that this is a string that is appearing in multiple lines. And remember what I talked about, the escape character. The /n shows that we need a new line. So there's a new line after the first print, after the first opening triple quotes. There's a new line after here, and on and on and on. So triple quotes allow you to do strings in multiple lines. Let me assign this to a variable, x equal that. Then I call x, and then I also want to do print x. I see what happens. So when I call the string on its own, it appears in one line, but it shows the escape characters. And then when I print it, it shows the actual output I intend with the multiple lines. But this is not commenting. This is just the string. But this is for documentation for functions, and you'll understand when we get there. In terms of multiple lines, you just have to do the multiple hash marks. Sorry, where is this? Where is this? Yeah, you just have to do the multiple hash marks. But remember, I showed you the shortcut. You can select a whole bunch and just use the control question mark to toggle. Yeah. Unlike C, where you have, I know for C, you can do the slash asterisk, and then you type in your code and everything, and then now you close it out. That's how you do the multiple line comments in a language like C. But for Python, you don't have something similar to it. That one you just have to use the hash. But then with the control question mark, at least it allows you to do that easier. That answer you?
Oh, okay. Yeah, sure. Thanks.
Welcome. Okay. Yeah. So I'll bring this triple quote back to the strings section. Yeah, let me come here. Yeah. So triple quotes allows you to have multiple lines, but this is used again documentation for functions. And even before we get there, I'll show you something else you can use in Python if you want to know what a particular function does. We'll touch on functions later, but just so that you know. So for example, you want to know what print does, and you can press Shift Tab, and that is going to return this box. If you press Shift Tab several, so you can so once pressing it once returns this box. If you type on the plus sign, it expands it, and you can scroll down and see what happens. Alternatively, you can press Shift Tab 1, 2, 3, 4 times, and you see down here it returns this window. And if you expand, if you click on this icon where my cursor is, it'll open that in a new tab, and it brings this page that shows what the function does. Print is not showing that much, but then there are certain functions that are very detailed, and it'll give like maybe a page or two of what that particular function does. So that is one way to find out what a particular function does. You might want to use something and you're not sure, yes, and you don't want to come out of the notebook environment to go to a different page. So just Shift Tab 1, 2, 3, 4. It brings it up, and you can see what's going on. And let me see if I can get an example of a function that has more than, let me see, range 2, and then I do Shift Tab. Okay, yeah, so this one has, no, that one is it's also small. Let me see, list, oh, sorry. No, this one, no, these ones all don't have as much information as I'd want to show you. So when the time comes, I'll show you what I'm trying to explain. But for now, yes, if you want to know what a function does, again, Shift Tab 1, 2, 3, 4. So Shift and Tab at the same time, but press the tab 4 times, and then you get the documentation of what that particular function does. Any question? So we've done variables, we've done numbers, we've done strings, and we've also looked at comments. Next thing we're going to look at now is the print and the format functions. Okay. Print just displays the output that you instructed to display on your screen. Remember, our very first program when we started was Hello World. So that's all that print does. Whatever you specify within the parentheses, which is the argument of the function, is what is going to be displayed. We've printed that string. You can print numbers, and it'll do the same thing. And you can print variables. So let's print that very long variable that I defined. Oh, I need to rerun that cell. Where was it? Here. Okay. This. So let's print that very long variable that I defined. So you can either print text or numbers or values that are in variables. If you don't define a variable and I print and I try and run print without it, say for example, I print sum, I get an error, sum is not defined. That's because I'm trying to print, if I don't have the quotes in place, then it's seeing these as a variable and not as a string. That's why I have that error. But if I was to add strings to it, quotes to it, and it goes ahead and prints that. So as you're working on your code, if you notice that you ask it to print a variable and it returned that error, that name not defined, then check back and either check the spelling of your variable name or check and make sure that it was actually defined. You notice that for this other one, when I was going to print this one, I had to go back and rerun this cell. That's because, remember, I'd restarted my kernel, but this particular cell had not been defined. You've seen in this cell name, I've defined name to Eric, but because I've not run this cell, in fact, let me just do and bring it back down here. Oh, sorry. Paste cell below. Okay. So if I run that, it's showing name is not defined. But if I run this cell and then I run this again, then I get my output. So that's something to be aware of. If you get that name not defined error, either check the quotes so that if your intention was to print an actual string, you add the quotes. But if it was a variable, then check the spelling of the variable or check to. Then what format does is that it allows you to use variables within your print statement, so that way, in case you have complex print statements, you don't have to keep changing values manually. You don't have to hard code values into your print statement. So let's say, okay, so print, today is Saturday and it is what? 20 degrees Celsius. So let me go ahead and print that. But you see, each time the day changes and the temperature changes, I have to go everywhere where this statement is and manually change that. I have to hard code the changes in all instances of my program. So let's define day Saturday. Temp is, let me just call the full word, temperature is 20. So print, so I can do one way of printing with variable names is you can combine the variable names and the text. So let's do that first to begin with. So today is space, and then I have day space, comma, day variable, comma, and it is space, comma, temperature, comma, quotes, degrees Celsius. So if I go ahead and run that, what do I have as an error? Saturday is not defined. Ah, yes. I forgot my quotes on Saturday. Okay. So I have my print statement has given me my output. Today is Saturday and it is 20 degrees Celsius. So here, if I change this to 340 and I change this to Monday, I get my new statement out in place. So you can do this. You can combine the different pieces of text. Okay, here I have an extra space, so let me remove that. Do I have an extra space? And it is, let me remove that. Okay, the extra space is in it. So that's one way of doing it, where you just build up your text bit by bit. You have whatever your text is, whatever variable is being called, and on to the end. That's one way of doing it. The other way of doing it is using the format function. So let me go ahead and so print today is, these are curly braces, and the curly braces are placeholders. For now, just type along and then I'm going to explain what everything is once we are done. Today is, and it is degrees Celsius dot format day temperature. So here we've just done everything within one continuous string within quotes, instead of breaking it down like this into text, variable, text, variable, text. We just have one continuous string of text. And then at the end, we now have the format function. And within the format function, we pass in our variables. The curly braces stand for placeholders. It's showing that within this portion, fill in a certain value. And what happens is that at the end of your string, outside the quote, you have the dot format. So basically you're saying passing this string to this function using these variables to return whatever output I need down here. And so the dot format is saying for the first placeholder, assigned to the variable day. To the second placeholder, assign it to the variable temperature. And then now print the output for me. Any question on that?
Not really. Just maybe an observation that I've checked is that when you're using the print function, you're also using the double quotes. Is it okay to use single quotes?
Oh, yes, it is entirely okay to use single quotes. So let me come here, single. Yeah, just be consistent. If it's double, stick to double. If it's single, stick to single.
Okay.
Yeah, it's perfectly okay. So now, some things to watch out for. Actually, before we go there, let's now go ahead and change our day to what? Wednesday. And our temperature is dropped by several hundred. Same thing. And then I rerun this, same thing. It automatically changes for me. I now no longer have to worry about changing this manually wherever this particular phrase appears in my code. It just automatically changes for me every time I update my variables. So I'll put this in its own new cell so I don't have to keep running that every time. Okay. Now, the problem with this is that you have to remember the order of your variables. If I was to flip day and temperature, of course, you can guess what's going to happen. Today is 30 and it is Wednesday degrees Celsius. So you have to be very cognizant of what the order of your variables are when using the dot format function. The order in which they appear, the order in which they're supposed to appear in the sentence is the order in which they're supposed to appear down here. And so make sure that you're very cognizant of the order. One way of mitigating this issue is if we can call this 1 and we can call this 2. And then first, let me return this to how it was originally. Day. Then now within the format function, you can say 1 is day and 2 is temperature. So this, if I run it, it still gives me the same result, that 1 day, 2 temperature. But now here, if I switch these around, I still get the same output. Because in this case, the placeholders have been given specific variable names. And so it doesn't matter in what order they appear in the format function. So long as I assign the correct external variable to the correct internal variable, I'll always get the output that I expect. This is good, say for example, if you have very many variables you need to keep track of. If you are working on a very complex print statement or whatever, and you don't want to be confused, then have your placeholders have additional variables in them. so that you're never confused as to what order they're supposed to appear in. If it's only 2, 3, or 4 variables or so, which is not that difficult to keep track of, then you don't need these additional steps. You can just list them out and in the order that is expected and just let it be. The final thing I'm going to show you is that, so temperature 30, and let's say yesterday temperature was what, 20, and let's have a new print statement. Print today is, and it is degrees Celsius, which is different from yesterday by degrees. Let me just see DC so that you can see by DC. So today is that, and it is that, which is different from yesterday by that C. Then dot format. So day, let me reduce this to, let me just do IT. T. I'm doing something very bad. You're not supposed to have single letter or single character variable names, because then you're confused at what is going on. The more descriptive your variable name, the better. So temperature is much better than T. Yesterday's temperature is much better than YT. But I'm doing this just so things can fit in one line, and so that you can see what I'm trying to do. So format. So we have day T, and then we have what, T minus YT. What do I have here? Oh, sorry, I haven't run that cell. Then I rerun this. What I want to show you is that you can actually have arithmetic operations within your format statement, so that you have your variable day. Today is Wednesday, and it is 30 degrees centigrade, which is different from yesterday by 10 degrees centigrade. So that's the beauty of format, that you can actually have mathematical operations within the format statement. Say, for example, you're trying to find out in Nairobi, there are 300,000 women and 437,000 men. And the percentage of the total population is women this percent, men this percent. You can actually work out the percentages within the format statement itself. So that, and actually let's go ahead and do that. So women 300, so 340, men for 343, that. And then so print, there are or that percent women and or that percent men, then dot format. So women, and then we have our parentheses, women plus men, women divided by women plus men. So let me do this. 100 times women divided by women plus men. So we have that. And then we have men. And then let's repeat this calculation. I'll just copy paste this code on here. And then I do replace the, and then if I go ahead and run that. So you see, there are 300 that or 46% women and that or 53% men. That's the beauty of the dot format. It allows you to do stuff like this. And once you go into some of the different data analysis problems and stuff like that, one of the examples will give, it will enable you to do stuff like this much easier. So that if I don't want to have to explicitly calculate this on its own line, if this is the only place I'm ever going to use this specific calculation, then I don't have to have it in a different line or cell. I can just incorporate that within the dot format function immediately, and I get this output in place. Any questions on print and format?
Hi, Eric. So if I wanted to have my Wednesday under quotation marks, how do I then go about it?
Wednesday in quotation marks?
Yes, in the statement. Today is Wednesday and it is 30 degrees Celsius.
Yeah, so we just add the quotation marks within that, but it would have to be with escape character. In this case, we have single. Let's just escape them. Escape. There you go. You just escape them within the print statement itself.
Also, okay, now I get it. That's fine, thanks.
Okay. Any other question?
No, just still typing.
Sawa.
Do you have a way to reduce the number of decimal places? Like that's a long decimal, like percentage.
Yes. Actually, I didn't want to do that. Now you can do that. There's a function called round. Okay. So you do that round, and then you specify the number of decimal places you want. This has to come outside there too. So that way, so it's round whatever value you want, and then the number of decimal places you want.
Okay.
Yeah, so I'll repeat the same for this as well. There, 2. Yeah, no, I got it in the wrong place. 2, no. It's after this one. Yeah, now I have to look at my, so there's that's the outer one, that is that one, that is that one, so round 2, women 1, 2. I think I'm missing, there you go, yeah. So it's round the value, actually let me just demonstrate. So round the value you want, so 3 point blah 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 blah, and then the number of decimal places you want. See what the, yeah, that's still a little okay. We can take maybe a 15-minute break. We'll come back, and then now we shall go into some of the collective data types. So we have lists, we have tuples, dictionaries, and all that. So it's 10, 27, 37, 42. So 10, 42, we shall be back.
Okay, sawa. Yep, here.
Dan, Emma, and Jacqueline back with us. Okay.
Eric, maybe before they come back, I was really having an issue where to find that the rounding part, where to insert that to.
Or where to insert it?
Yeah, in the midst of all those brackets.
Yeah, no, it's confusing. So it will have to be. So what I have highlighted. So that's the calculation that I'm working on. So it's going to be round open bracket, then that calculation, and then now comma the number of places and the closing bracket.
Yeah, especially the last one that has so many brackets. I was having trouble.
Yes. Yeah, that's even for me. Remember when I was doing it, I was having issues, but yeah, it's that.
Okay, no, this is just the beginning. Okay.
But taking it slowly.
Yeah.
Okay, so we can go ahead. We're now going to look at collection data types, and we're going to start with the list. So let's look at lists. So a list is just collection of data types, and they're enclosed in square brackets. It's used to show, it's just a collection of different types of data, and they don't have to be the same. They can be different types, but at the very basic, it's like I'd shown you earlier above. So let's look at my numbers, and let's call, and you assign to a list, you assign the collection within square brackets. You've seen the curly braces, you've seen the parentheses for the functions. Now you're seeing the square brackets. The parentheses and the curly braces also help you define different types of collections of data types. But for lists, you use the square brackets. And my numbers, if I was actually just to leave this as is, and then I call my numbers, I get back this empty list. You can do that. And you'll see situations where this is something that you're supposed to do. But in our case, let's populate it with numbers. So it's the item separated by commas. So 1, 2, 3, 4. So I go ahead and I get back my list of numbers. Then you can also have a list of strings. So my strings, and for that we shall just assign different names. Second. So I'll have, okay, so Eric, Dan, just going through my list, Emma, we have Jacqueline and Kelvin. Then if I go ahead and call my strings, I get back my names. As I said, you can have different types of items in your list. So let's go ahead and create a mixed list. So my list will have, let's just repeat that. So Eric, Dan, 324, books, then if I go ahead and call my list, so you see now here I have a list that contains strings and numbers. And actually, if I just change this to a float number, so I have strings, I have integers, and I have floats within my string. Lists allow you to do that. And to take it even a step further, you can have, pardon me, you can have a list of lists. So my list of lists. So in this case, I'll just use what I already have. Actually, let me start. Yeah, so my numbers, my strings, and my list. Remember what I'd said before, that when you use a variable name in a computation, in an assignment or whatever, you don't use you don't use it as a string, and so you don't include the quotes within it. So in this case, it's just going to return all these three. But if I was to go ahead and also add an additional my list, you'll see the difference. Oh, then I need to call it my list of lists. So you see here, I have my list of lists. The first item on that is my first list, which was of numbers. The second item is this list of strings. The third item is this list of mixed values. The fourth item is a string called my list. So lists allow you to do that. And as you can guess, you can have lists of lists of lists of lists, as in you can go as deep as you want. For readability and maintenance of your code, you might want to not go beyond maybe 3 levels deep. For that, you might want to use something that's more efficient. And when we go into NumPy, we look into something, into arrays, which is more efficient for handling that kind of thing. But yes, you can do that. You can have lists of lists of lists. So that is how you define a list. Any question? And then if you...
maybe just before you go on, the last one, my list, why is it in quotes?
Oh, because I was showing the difference between calling a string and calling a variable.
Oh, okay.
So yeah, so this one I'm calling the variable my list, which is going to return this third list. But here with the quotes, then I'm just calling the string my list. And that's why down here, it appears as a fourth item in my list.
Okay, got it.
Okay. So now that we've gotten what the lists are and we've defined our list, we can go ahead and look at operations on lists. So some of the things you can do, you can get the number of items in your list. So let me do. So if you want to find out what the number of items in your list is, then you use the len function, L-E-N. And then the argument is going to be, you're going to pass in the name of your list. So in this case, we had my numbers. And what it does, it just counts the number of items in your list. We had my strings. There are 5 items in that list. We had my list. There were 6 items in that. And then we had my list of lists, which has the 4 items. So that's what you use. Len parentheses, then the variable name. You can pass in an explicit list. So let's do, let me delete that, 1, 2, 3, 4, and it'll do the same thing. So you can either pass in the variable name specifying the list, or you can actually pass in the list itself. So that's how you get the number of items in a list. Then there's something called indexing. And indexing allows you to access individual items in a list. Basically, it's just saying, how do I get the item in this position in the list and show it or perform whatever operation I need to perform on it. So let's go ahead and let me just generate my list, and I'll have just simple number. Let me use the my strings so that my list is going to show the list of names in this class. Okay. The first thing I need to mention before we go into indexing is that Python is a zero-based language, zero-based indexing, which means it starts counting from zero. Unlike a language, for example, R, which is another language you can use like in data science, R starts counting from one. Your first item in anything is one. But in Python, your first item in anything is zero. So you start counting from 0, 1, 2, 3. That said, let's now go ahead and do some indexing. If I want to get the first item in my list, I need to call my list, and then I use square brackets. And within that, I pass the value, the index value that I want. In this case, I want the first item. So the first item, remember, is 0, and it returns Eric. If I want to call my list, if I want to call the third item, so it's 1, 2, 3. However, remember, I start counting from 0. So it's going to be index position 0, 1, 2. I have to pass in the value 2, and that returns Emma. So that's how you access the different items in your list. If you want to return, if you want to find out what the last item is, you could count. You could say 0, 1, 2, 3, 4. And then if we pass that in place, my list 4. And of course, it returns the last name on my list. But assuming you have a list that has 600 items or 7,339 items, and you're not sure of that number itself, instead of passing 7,339, a shortcut is just passing -1. So my list in square brackets -1, and it returns the last item. So basically what happens when you're counting from the right, you start counting from 0. So this is 0, 1, 2, 3, 4. So if you start counting from the left towards the right, you start counting from 0. So Eric is 0 all the way to Kelvin, 4. But if I'm counting from the right back to the left, I start counting from -1. So this is -1, -2, -3, -4, -5. So from the right going to the left, you start at -1. From the left going to the right, you start at 0. So now, like for example, and because of starting at -1, this way then you can have the actual numerical value indicating the correct numerical position. So this is -1, -2, -3. That intuitively makes sense. But from left to right, remember it's from 0. So 0, 1, 2. So here we had the third item was my list 2 returned Emma. If I was to go ahead and use the negative indexing instead, I'll do my list -3, and it will still return Emma. Any question on that? look at something else that uses indexing called slicing. So for indexing, it is using the numerical position of items in the list to return the to show them and to display them for you, or to use them in whatever computation you need to use. So in this case, if I wanted to use Jacqueline, I'd either do my list 3 or my list -2, and it will return that value, and I'd use it in computation or whatever it is I'm trying to do. Slicing allows you to return a range of values from your list. And basically, this is how it looks like. So let me just actually have it down here. So it is list name, then the square brackets, then you have your start value, then your stop value, and stop value +1. And I'll show you what that means. Let me include this on here. So slicing, the name of your list and your start value colon your stop value +1. Remember, like I said, Python starts counting from 0. And so anytime you want to have your start value, you have to take that into consideration. So let's look at this. So my list, let's say we want to get the first 2 values. So we want to get Eric and Dan. If I pass in my start value is 0, that's where I want to start. My stop value, if I put 1, what's going to happen? I'm going to get back just Eric. The stop value is exclusive. So whatever the stop value is, if you want it as part of whatever is returned, it has to be from 0, which is my start value, to 2, which is my end value for Dan, and I get back my 2 values, Eric and Dan. Let's look at something in between. Let's say I want, I'll just recall my list here so that we have it visible. So let's say I want to get Emma and Jacqueline. So Emma is position 0, 1, 2. So my start value is going to be 2. So my list, my start value is 2 for Emma. And then my end value is, so this is 2, 3, 4. Because I want Jacqueline, I have to have 1 more. So that's 2, 4. I get back the 2 values, Emma and Jacqueline. If I wanted to get all the way to the end, I could do this. So it is my list 2. Remember, since I want 1 more than the end, the last one is 4, then I have to go 1 over, which is what? 5, even if it's not on the list. And I get back my last 3. So now that I've shown you the basics of slicing, I'll show you some things that you can do as shortcuts where you don't have to use a start if it's a certain way or a stop if it's a certain way. If I want to get the values back from a list from the beginning all the way until a certain number within the list, I don't have to specify the 0 as a start value. I can go ahead and do my list, leave out the first value 0. I want to start from the beginning, colon, to wherever it is I want to go. So if I want to get Eric, Dan, and Emma, so it's going to be 0, 1, 2. So my stop value is going to be 3. And I get back the first 3. So I don't have to specify what the beginning is. So this is basically saying, get me all the items from the beginning of the list to this stop value. And similarly, if I want to go all the way to the end, So repeating this example in cell 90, my list, my start value, I want you to give me all the values from the third value, in our case, Emma, to the end. I don't have to specify what the end is. And I get back my items from the list. So if you're doing anything from the beginning to a certain point, you don't have to specify the 0. If you're doing anything from a certain point to the end, you don't have to specify what the last value is. Remember, in this case, we had to do 1 more than 4, which was our last value to get 5. But because you're going to the end, you don't have to specify what that end value is. You just leave it empty, and Python is intelligent enough to return the items from that starting position to the end. Any questions on indexing and slicing? Okay, we can now proceed to, okay, yeah, Dan, you had a question?
Yes, what if I wanted to pick Dan and Jacqueline?
Let me see. Python does not allow you to do, the vanilla Python will not allow you to pick specific items from the list. And that's, again, you'll see is a disadvantage of Python. So if I do my list, you said Dan is position 1. You'd think you do 1 and then, so Jacqueline's position, we said 4, no, 3. This is going to return an error. It won't allow you to do that. It shows you that list indices must be integers or slices, not tuple. Well, that's something else. It's sending an error because it's thinking that I'm returning this. After this, I'll look at a different sequence type called tuple and I'll explain what that is. But this is the error you get. It won't allow you to do that, unfortunately. And that's, you'd have to write code that will return this for you. Like maybe get a for loop and say, go through my list and get me the position from this, the item from this position and the item from this other position. That's one way of doing it. I'm not going to go into that because this is a very high-level overview introduction, but on the side we can chat on that. What I will say is that when we go into the numerical Python library, you'll see how you can use NumPy to select specific items from your array. In NumPy, we don't call them lists, we call them arrays because it's a different structure altogether. You'll see how to do that. And then beyond that, when we go into pandas, where we're now going to look at tabular data and everything, same thing. When we do the slicing in pandas, you'll see how you'll be able to select specific items from like a column or whatever in a way that you'd have to do a lot more code to execute from a regular Python list.
It's okay, thanks.
So. So now let's go ahead and change items in list. So there's several ways where you can change items in a list. The most straightforward way is just using the indexing. So my list, let me go ahead first and call it so that we have it referenced. So say we want to change, to replace Emma with Catherine. So what you do my list. Emma's position is, remember, 0, 1, 2. So we have that position, index position 2. And then now you just put Catherine Then when we call my list, you see we've now changed the values in position, index position 2, which is the third item in our list. That's the most straightforward way of doing it. Then, so that is now changing the item on the list. You can also add items to lists. Okay, so there's a changing items. Got that. So we've changed the items where you've seen we've replaced a certain value in the list using the indexing operator to get back a new item. You might have the question, is it possible to change like a range of values? That's not possible. So my list 1, 3, in this case, I'm changing. Remember, we start counting from Dan, 3. So this is 0, 1, 2, 3. So it's going to do Dan and Emma. So if I do that, and then if I do, oh, my list is already this new one, sorry, Dan and Catherine. And then I do, I'd have to pass in a list, what? Alice team. This will return an error. Oh, it actually did it. Let me see what my list does. Ah, okay, yeah, that you can do. I wasn't aware, I wasn't very sure of that, but yeah, clearly you can do that. So you can actually specify a range, and then so instead of just having specific index position, you can specify this range. So in this case, we said go to the first position and go to the second item on your list, which is index position 1, and the third item on your list, which is index position 2, and replace that with these values. But you have to pass in the list that you want to replace those values with. So it is, you specify the range you want and a list of the values you want to return in that range. What it won't do is what Daniel had asked earlier. It's like if I want to return, so in this new list, I want to replace Alice, Tim, and Kelvin with others, that it won't do because there's something in between. But if it is a continuous range, that it can do. Any questions? So now let's go ahead and add items to list. So we've looked at getting the number of items. We've looked at indexing, at slicing, and at changing items in lists. So now let's add items to lists. Add items to lists. There are different ways you can add items to lists. Let me go ahead and just use the original list. So let me rename that. My strings. Where did I define? Yeah, here. Let me do that. Do that. Okay. So we have our original list as we had defined earlier. So there are different ways you can add items to lists. The first one is using a method called append. And basically what append does, it just takes the item that you want to add and it adds it to the end of the list. And being a method, what you do is that you call your list my list and then .append. And then now within the parentheses, you append the item that you want. So in this case, we didn't have Catherine in our original list. Let's go ahead and add that. So if I call my list, actually what I need to do, I want to run this command and then run it, call the variable in a new cell, and I'll explain why. So now I have Catherine added to the end of our list. The reason I did this is that each time you run append, if I run that again and I call the cell again, Catherine is appended again to the end. So every time you run append, it appends that value to the end of your list. Does that's something to watch out for. So that you might want to, probably if it's a one-time thing that you're adding, have that in one cell, do the appending, and then go to the next cell and call the list. There are situations where you'll find that it is very useful to have this. We'll have, remember I'd mentioned how to define an empty list is, okay, let me just redefine it. My empty list is just calling the variable name and assigning this empty square brackets to that. There are situations where you might have something that you're programming and you need to populate this list based on the output of certain computation that you're working on. Now, append becomes useful in that you define your empty list, you run through your computation, and every time your computation does something, it appends a new value to that list. That is now the use case for append. Any questions on that?
I think you might have to run through that once more. I didn't quite catch everything there.
For append?
Yes, for append.
Okay. So what append does, so that I have my original list. Okay. I do not know why it is doing. I know why, and I shall explain why you're seeing that a bit later. Okay, go back here and let's come back down. Okay. Let me remove my empty list, come back to my. So we have our original list on here. What append does, it's a function that takes in a value and adds that value to the end of the list. So this is a method that is attached to the list object. Method is a function that, that works on certain data objects. In this case, the list object, the list data structure has got certain functions that work with it. And one of them is append. So that's why you're saying, that's why you see us accessing this function this way. The name of your list dot append. The same way we had the dot format on here when we were printing, which is a method that is assigned to the print function. In this case, append is a function that is assigned to the list object. And what it does is that when you call it with a value, it's going to add that value to the end of your list. So in this case, we are appending the name Catherine to the end of our existing list so that it appears at the end of the list. Is that clear?
Yeah, so it's a method of adding to the list, but it only adds it to the end.
It only adds it to the end.
Okay.
Okay.
Right.
So there's that one. Then the next way you can add an item to the list is using the method insert. And as you will guess from the name, insert allows you to add an item at a specific position. So we have my list dot insert. And the way it works, you specify the position where you want to add that new item. So in this case, let's add it in the third position, which is index position 2. So it's going to come between Dan and Emma. You specify the position you want, and let's add Alice's name to that. And let's call my list. And now I get Alice added in index position 2, which is the third item of my list. And everything is now moved over to the right. Is that clear?
Yes, it is.
Okay. So those are the two different ways so far that we've seen how you can add an item to the list. There's a third way that you can add an item to the list. Say, for example, So let's say new names is equal, let me say team Ernest Fiona, new names. I could decide, okay, I want to add these new names to my list. And you'd think that, let me go ahead and say my list dot append new names. But if I do that, you see what happens? I have my original names, but then I expected to have a continuation of this single list. Instead, I have the new names, and then I have a list of the names added at the end. So it's Eric to Catherine, and then a list of Tim to Fiona. But this is not what I want. I want each of these names added individually to my list. And that is where now, and that is where we have a new method. It's called extend. So instead of using append to add it, and so I add the entire list, I use extend. And basically I'm saying, get this new list, get each item from this new list, and just add it to the end of the existing list. So let me go ahead and redefine my list, my strings. I need to copy that cell so that I have it down here. Edit, copy. Where are we? Okay, so let me define that, define my list. Let's append Catherine. Let's insert Alice. Okay. So now we've seen that if I'm going to append, if I use append with these new names, it just appends the entire list. So instead of doing that, we have a function called, a method called extend. So it's my list.extend, and then I pass in the name of the list whose names I want to extend from, so names, then my list. And this time you can see it has picked out the individual names from the new names list and just added them to the end of my list. So it has extended my list using the names in the additional list. If what you want to add is the actual list itself, use append. If you want to insert in a specific position, and even I could have used insert to insert this new list in a different position. In fact, let me go ahead and do that. So my list.insert position 3, new names, my list. And you see it has inserted that new list in this position. But if I want to just add the individual items from a list to another list, then I use extend. Any questions?
Yeah, when you're using extend, can you extend to a specific position?
Let's see. Let's see what it says. Extend list by appending elements from the iterable. No, because it's just appending. You can only extend it to the end.
Okay.
Yeah. Any other question?
And then why is it listing kama kuna line breaks, not single line list?
Oh, because past a certain number of items, then it's going to be displayed this way. This is just exact the same thing as this, but once it gets past a certain number of items, it is displayed vertically instead of horizontally.
Okay.
Okay. So we've seen how we can add items to lists. Now let's figure out how we can remove items from lists. So so there are different ways you can do that. Give me a second. One, you can use the remove method. And all you need to do is my list.remove, then the name, then whatever item you want to remove. So in this case, let's remove Tim, then do my list. And you can see we no longer have Tim between Catherine and Ernest. We've removed that item. So that's one way of doing it. The other way is using the pop method. And what pop does, .pop, without any argument, it removes the last item in the list. So in this case, if we were to run this and then we call my list, you notice that it has removed Fiona from the end of our list. If you have an argument in it, so my list.pop, let's say we want to remove this list within our items. So this index position 0, 1, 2, 3. You put the position of the item you want to remove. In this case, it's 3. And then if we call my list, we no longer have that list in that position. So those are the two ways to remove items from your list. Any questions?
In the my list dot remove Tim. When you called out my list, I still can see Tim.
That's because you remember we removed. Oh, give me a second. That's because, so we have this list that has Eric, Dan, Alice, Emma, Tim, and what have you. But here I removed Tim.
Yes.
I removed this team. But there's this other team which is part of a list. You see now here between Catherine and Ernest, we don't have Tim. But there's this team which is part of this list.
Oh, okay.
And then when I did, yes, and then when I did now the pop to remove that, it's now Tim no longer appears in my list. Okay.
Okay. Yeah, thanks.
Any other question? So from there now, let's go ahead and do ordering of items. For this, let's define a list of numbers. So there's the sort method. And basically, as the name suggests, it just sorts the list. So if we do num list.sort, And basically, that's what you do. You just call it. It's not going to return an output when you run it. But what happens is that it sorts the list in place and automatically reassigns the sorted value to that variable name. So if I can go ahead and call num list, you see now my values have been sorted from 0 to 7. If I want to sort them in reverse order, then what I need to do, let me go ahead and assign that variable. Let me make sure that we have the list all jumbled up. Yes, we do. So if I want to go ahead and sort, instead of sorting from the lowest to the highest, I want to sort from the highest to the lowest, then I have to add an additional parameter to my sort method. And that is the parameter reverse, assign that to true. So that when I call my num list, I now have my list sorted from the highest to the lowest. Then, so there's that one sorting, which sorts in specific order. Give me a second. So yeah, so sort, we've seen without any parameter goes from the lowest value to the highest value. With the reverse parameter in place, it just sorts from the highest value to the lowest value. Then I'm going to introduce another method. It's called reverse. And that is going to do something counterintuitive from what you're thinking. Here, reverse, remember we used it as a parameter and it just sorted from the highest value to the lowest value. What reverse does, it only reverses the order of the list. It does not sort them in any way. It does not sort from highest to lowest or lowest to highest. It only reverses the order in the list. So before that, let me go ahead and redefine that variable. And then I have reverse. So, and my list dot reverse. And what this one does actually, yeah, so it reverses and then let me call my list. Let me rerun this again first. Oh, sorry, num list. Sorry, not my list, num list. Num list. Num list. Okay. A second. Okay. Let me remove these 3. That's confusing me so that I don't have 3 in place. Okay. Okay. So there you go. So you've seen that num list up here, we have 3, 4, 6, 1, 0, 6, 2, 7. But when you reverse it, you get the opposite, 7, 2, 6, 0, 1, 6, 4, 3. It doesn't order them in any form, in any way, from highest to lowest or lowest to highest. It just gets your list and it flips it around. If I was to run this, you see I get back my original list. So every time you run it, it just reverses it. It doesn't do any ordering or whatever. It just gets the original list and reverses the order. The way the items appear in the list, the order is just inverted, so that whatever is first comes last, and on and on. Any questions?
So there's no function for ordering in descending.
There's the ordering in descending. You remember, as in specific, apart from sort, no. You have to use the sort method and just have the additional parameter reverse inside it.
Okay, so by default, when you sort, it is in ascending order.
Yes, when you sort, it is in ascending order.
Okay.
Yes. This, give me a second. So you remember, so let me get num list. What do we have it here? We have it that way. Remember from slicing, if I wanted to get the values, if I wanted to get the value, can I do that in Python or my away? Give me a second. Let me try something. True. Yes. There's a thing I wanted to show you. For slicing, and something I think I should also have mentioned while we were doing slicing, is that remember we were able to get the values of our list. We said that if we want to go from the start to the end, you don't specify the start to a certain value in the middle. You don't have to specify the start value. Or from a certain position in the middle to the end, you don't have to specify the end value. And that we had the start value and the stop value. But the other thing also you can do with lists is you can actually get every other value. So let's say I want to go from this from index position 1. I want to go, so this is 0, 1, 2, 3, 4, 5, 6. And I want to go to index position 6. And so I'm going to call out index position 7 to index position 7. And then if I add an additional parameter, so if I leave it at that, it's going to return these values from index position 1 to index position 6. But if I add an additional parameter, say I want to return every second value, it now only returns every second value. From index position 1, which is value 2, it skips 6, returns 0. It skips 1, returns 6. And since my stop value is 7, it stops there at 6. If I was to do this, so instead of defining the stop value 7, I just say go all the way to the end. So from index position 1, which is this value 2, skip 6, return 0, skip 1, return 6, skip 4, return 3. So if I run that, I get that value. I should have mentioned this in the slicing, but I forgot. But at least it's good that I've remembered it now. So this still within slicing. But and then again, I can decide I want everything, return everything in the list, but only the nth value. So in this case, let's now say every third value. So it goes through my list. So it returns, so it's going to return the first one, skip the second, skip the third, return this 0, skip 1, skip 6, return 4. So that's how you return every other value from your list. So you specify the beginning and the end, and then the third item will be the interval by which to skip the items in the list. And the reason I remember this is that assuming now you have your list and you want to sort it in reverse. So what you do, you'd say return the first value. Start from the start value, end at the last value. But instead of having a positive integer for the interval, let's do -1. And it reverses my list for me. So it's just saying go from the beginning to the end and then invert the list. So you can either use the sort and the reverse equals true, or you can use this notation where you decide from the start value to the end value, but then they flip the values using -1. And similarly, you can do the same. You can reverse, but reverse after every other number. Any question? Anybody would like me to go over that again in case it hasn't been too clear?
Afadhali.
Sawa sawa. So we have my num list. So we have our list of numbers on here. If I want to remember under slicing, I could decide I want to get numbers from index position 1, which is the second item on my list, to index position. So this is 0, 1, 2, 3, 4, 5, 6, to index position 5, which is 0, 1, 2, 3, 4, 5, index position 5. But for me to get index position 5, I have to go one more and call 6. So I need to go from num list from 1 to 6. So that returns these values, 26016. Start position is 1, end position is 6, which is 4. But because remember that it only returns 1 less than the end, it returns the value 6. Are we okay until there?
Yes.
Okay. Then we also said that if you want to return values from the beginning to a certain position, you don't specify what the beginning value is. It assumes automatically that if you don't, that you're starting at the beginning, 0, but you specify what you want your final value to be. So let's say we want to return 7260. So this is 0, 1, 2, 3. And stop value has to be 1 more than what you want to return. So in this case, we specify from 0 to 4. You don't specify the beginning, but you specify the end. We get back our values. And similarly, if you want to do to the end, you say num list, and you specify from where you want to start. Let's say we want to return just the last 3 numbers. So this is index position. So 0, 1, 2, 3, 4, 5. So our starting position is index position 5. And since we're going all the way to the end, you don't have to specify what the end value is. Python knows if there's no value, you want everything from that to the end. And we get back 6, 4, 3. Are we okay till there?
Yeah, that's okay.
Yeah, we're okay. But what if we had duplicate values? Let's say we had the 4s are duplicates. So which 4 will it pick?
It will pick whatever in. You see here, you're not picking by value, you're picking by position. So let me do num list. Let me do exactly what you're talking about. Let me add 4. Okay. So you're talking of this situation?
Yes.
You see, we are not picking by value, we are picking by position. So if I was to run this, it returns from index position, whatever index position it is, all the way to the end. So I'm not picking, I'm not saying that go through my list and get me this value. I'm saying go through my list, go to this position, pick the value at this position. Is that clear?
Line 157.
Line 157. Line 157 is saying pick the values from the beginning to the item that is in index position 3. Because remember, 4 indicates that I want you to return, 4 indicates the stop value, but the stop value is always 1 more than the item that is going to be returned. So in this case, it's going to return 7260. You see, 4 is not even featured because this 4 does not indicate this 4 or this 4. It indicates the position. Actually, let me do this. Let me say my list is, let me use letters instead of numbers. B, C, D, E, F, G, G. Okay. Oh, sorry. Okay. And then let me do this same thing. My list from the beginning to 4. It only returns the first 4 letters.
Okay.
Is that clear?
Yeah, that's clear.
Okay. Yeah, so this 4 does not indicate that return the value. It just says return, it's just a stop index position. So return everything until this top index position -1. Is that clear?
Yeah, so
hi, Eric.
For this case, okay, go on.
No, sorry, I just wanted a repetition on line 146. I think that for me, that is where I got a bit confused because I thought she was still trying to reverse the after sorting, what exactly are you trying to do on 146? And what is this result?
Okay, so let me start from sort. Let me redefine that. So what sort does, it takes your numbers and it just sorts them from descending from the lowest value to the highest value. So in ascending order, that is what sort does. Understood that?
Yeah.
Okay, then now let me redefine my list. If I want to,
so even that one is clear for me. It's 146 that I'm a bit confused.
Okay, 146 only reverses how actually, even for this one, let me use letters instead of numbers. So let me do, I shall use my list instead of num list. My list. Oh, sorry, it's not there. It's reverse num. My list. My list. Okay, let me add this so that we have it for reference. My list. So we have my list here, ABC. Reverse only reverses the order in which the letters appear. Oh, sorry. Actually, I also want to do this so that it's not alphabetical. So let's say A, X, P, what? E. Okay. So we have a list here that has these letters A, X, P, E. Reverse only looks at the list itself and goes from the end. Whatever is at the end is now coming to the beginning. Then the next comes second, and then the third, on and on. It doesn't reorder. Exactly. So, and every time you run this, you'll notice that it just flips it.
Okay, makes sense. Thanks.
Okay, good. Welcome. Dan, you still had an additional question?
Yeah, just where you've been explaining about X, P, and E. So you can't use sort here. Sort you can only use when we have numbers. Huh?
No, you can use sort for letters as well. Let's go ahead and do it. So my list dot sort my list. You will get it. It'll sort alphabetically for you.
Okay.
And then let me go ahead and redefine that. And then if we do reverse equals true, same thing. Sort will work with both letters and numbers.
Okay.
Yeah, thank you for asking that. The only thing that I have to mention is that if I have no, let me have, what letter don't I have in place? M. My list M. So if I do, you notice M uppercase comes before A lowercase, even if intuitively we know A comes before M. What sort does is that it first sorts the uppercase letters and then it sorts the lowercase letters. So that's something you need to watch out for. If you're trying to do this kind of thing, the explanation behind this is that it looks at the ASCII representation of the letters, and the ASCII value for uppercase letters comes before the ASCII value for lowercase letters. That's why you get this kind of result. So you need to watch out for this. If you're using sort and you have like a mixture of uppercase and lowercase letters, the best thing to do will probably be to change everything to the same case and then use sort. Otherwise, you're going to run into this sort of problem. Is that clear?
Yeah, that's clear.
Okay. So yeah, I was back to Kelvin's question of this list and stuff. So we've seen from beginning to a certain point. We've seen from the end, from a certain point to the end. Let me just make sure that I have my numbers redefined so that, okay. Then now the next thing I wanted to show you was that you have your list of numbers, and say you want only to return every nth number. In this case, we want to return only every second number. So for that, num list square brackets. So we are getting everything from the beginning. So you leave the start blank because it's everything from the beginning. You want to go all the way to the end. So you leave the stop blank, colon, and then you specify the interval you want to skip. In this case, we want to return only every second number. If I did 1, it will just return the entire list on its own. That doesn't make sense. If I, and it's also the same thing as just doing the no start, no stop, no interval. It's the same thing, that and 1, sorry, this is supposed to be 1, not. That and 1 just does the same thing, meaningless. But if I want to return every second number, and then I put 2, so it goes from the beginning, it skips the first one, returns the second. I mean, sorry, it will always start with the first one and then skip however many it needs to before it goes to the next one. So bring the first number, skip the second, bring the next number, and on and on and on to the end. Up to that, we are together?
Yes, there we are.
Okay. If I want to reverse my the numbers in my list, you remember that I showed you that if I did an interval of 1, it just pretty much returned my list for me. But if I want to do this, let me switch this back to 2 seconds. I'll actually do that here. So that 1, it just returns my list for me. But if I want to reverse this, then the way to do that is instead of +1, I do -1. Remember, counting from the right, you start at -1. With +1, it just returned from what was at the beginning. It didn't skip any value and went all the way to the end. But if I say start from -1, I'm telling it start from 3 and come back towards the left. So if I run that, I now get back my list, but now in the reverse direction. That clear?
Yeah, I can see that, yeah.
Okay, you've seen that. But now, if I want to do the same thing, I want to reverse the order, but then now also skip certain numbers. That's now when I go ahead and instead of -1, I'll replace this with -2. And it'll do something similar to what happened here. It will return 3, skip 4, return these other 4, skip 6, return 1, and on and on. So you've seen that? Okay, that clear?
Yeah.
Yes, it is. So the first one was skipping from left to right, and the last one we've just done is skipping from right to left.
This 203?
Yes, 203 is right to left, right?
203 is still, yes, 203 and 202 are right to left. 200
yes,
is left to right.
Left to right, okay.
Yes, sawa. Okay. Let me see. I want to do, okay, how split string. Let me do 2 more things and then we can take a break and then come back and finish on a couple of other data structures. Okay. Then another function that you can use there are certain methods that you can use to convert strings into lists. So let's go ahead and look at them. Convert strings to lists. Oh, sorry, this is supposed to be markup. Okay. So let's have my string equals My name is Eric. My string. So I can, the first method you're going to look at is split. Split. And basically what split does, it takes your list and then it splits it into individual elements. So let's do my string dot split. If I run that, I get back a list of the different elements in my string. But it does that, you notice it does that, it gets the first word, then second, third, and on and on and on. By default, without any parameter in place, it uses the space as the value with which to split the string. If this didn't have any spaces, and then I ran that and I rerun this, there are no spaces, and so it just returns it as a list of one item. But with spaces, you get the 4 different words. If I had something else in place, instead of spaces, I had dashes, same thing. If I ran this, I'd return just one item, a list with just the one item. But if I specify my delimiter is the dash, and then now it knows that on the dash, split it, and then it returns the 4 words as expected. And similarly, so instead of that, let me say I want to split on M. And you see, it returns these 2, minor, A is Eric. So it has these 2 items. So whatever character you specify in here is the one that it's going to use to split the string into a list of items. Very simple use case. Say you have got people who've subscribed to your mailing list and you only have their email addresses and you want to find out what their domain name is. You guessed it, you just split on the @ symbol. So let's go ahead. Tonga@gmail.com. Email is that, and then I can say domain, or rather, yeah, let me just say split email is email.split. Actually, let me just not assign it a variable. Let me just split it directly. Then we can get back the value. Email.split. And I want to split it on the @ symbol. And I get my name and I get my domain. That's how you're able to now just extract names from email addresses. And then now from this, you can go ahead and access it in certain ways and do whatever functions you need to do. So let me say email list equals this.
GS ako hapo chini.
Okay, so email list is that, and then I want to return only the names. Oh, sorry, it's email list. So you see that way. So you've seen a use case of how you can use the split method and indexing to generate a list of names from a list of email addresses that you have. And then taking this example even further, you remember the append method. So you can come up with a loop that allows you to go through a list of email addresses. You use the split method to split it between the names and the domain. And then you use the .append to append each name to your list. Now you start seeing use cases of some of the things that we are doing. Any questions so far? Then the other thing I'm also going to show you, so you've seen split. There's also another method. It's called list. But list is a method that you operate on on strings. So list. A second. So there's, give me a second. So we have list. So let's still use my string that we had before. So I'll actually remove the hyphens on here and return the spaces and reassign that. So my string. So we have my name is Eric. You've seen that we used split to split it into the different words within the string itself, and without a parameter, it splits on the space. But if you have something you want to split it on specifically, you assign that within these parentheses. In this case, you are splitting between the hyphens. But if you use list, what list does, it breaks down the string into each individual character. So we have list, my string. You see now we get back a list. So it goes through the string and extracts each character and adds that into a list. If I was to replace this with the hyphens, again, we'll now get back each character will be broken down, and you'll now with each character. And a use case for this probably would be, say you want to extract specific, or rather you want to filter out certain characters or something. So it might be more effective for you to get the list of strings, and then you can filter out whatever character you don't need, and then you recombine the string in a way that you want to do so. And we'll have examples of all of these things as we go along and we look at some of the data analysis examples. We'll come across situations where you see this being practically displayed and being practically used for whatever tasks we need to do. Any questions on this too, on the list and the split?
I think it's okay for now.
If not, it is now noon. I propose we take a 10-minute break. Yeah. I'll get these. There are certain exercises. I'll see if I can get them and share with you that will help you do all these practices and all. So let's take a 10-minute break. We come back, and then I'm going to finish up. There are three more. Let me see, three. So there are two more data structures I want us to do today. And then we'll end from there. So there's the tuples and there's the dictionaries. And then now we'll just proceed with whatever is left next Saturday. So 10-minute break, it is 12:03. We'll be back at 12:13. Yeah, we'll just spend like about, thank you. We'll just spend about 20 or so minutes looking at the last two collection data types, and then we'll pick it up from there next week. me see. Sorry, not lists, but tuples. So we've looked at lists as a collection data type. And the thing about lists is that, as you have seen, you've been able to make changes to it. You can assign new items, you can remove other items, you can replace items. That's called a mutable data type, meaning it can mutate, it can change. We have another data type, it's called a tuple. This one is an immutable data type, which means that it cannot change. You cannot mutate it from one thing to another. And the only way to make changes to it is to completely reassign a new tuple to the variable if you want to make any changes. It's in all ways, it is exactly like a list, other than that one fact that it cannot change. And the fact that it cannot change means that any operations that we've used on the list that have resulted in changes will not work for a tuple. And there are use cases for either of them. So let's go ahead and create my tuple. And for that, an empty tuple is just an empty parenthesis. So if I go ahead and I need to change that to Y. So if I go ahead and I call it, I get back my empty tuple. If I want to have values in it, so 1, 2, 3, 4, I get back my tuple and it has the 1, 2, 3, 4. And you'll notice that unlike up here, it's reported with the parentheses, as opposed to here where we have the square brackets. If I was to do, let me see, where do I have? So if I did type email list from what we had before, you notice that it returns back the type is a list. But if I do type my tuple, it returns back that it's a tuple. You can index a tuple just the same way you were able to index a list. My tuple, so I want to get item in position 2. Let me just add some more numbers here. Actually, I'll use the same numbers I had used for this num list. Okay. So say I want to get item in index position 0, 1, 2, 3, 4, which is the value 1. So I pass in 4, I get back 1. Just like lists, you can get from beginning to a certain index position. And you'll notice that for indexing, I'm using square brackets. Definition, you define it using the parentheses, but for indexing, it is always with the square brackets. And then similarly, I can get, okay, Dan, I've seen your question. The difference between tuples and lists is that lists are mutable, they are changeable. You can change the values within a list. A tuple, you cannot, they're immutable. You cannot change the values. And I'm going to demonstrate that. For now, let me show the similarities and then I will go to the differences. So we've seen that you can get a specific value from an index position. We called the tuple with the index position 4, we got back 1. You can do a range from beginning to a certain value. You can do a range from a certain value to the end, or anything in between. Three to 7, we could do 6. You go back. Okay, so we've seen the slicing. So my tuple beginning to end, skipping a certain value, and it's going to return that. So in terms of indexing and slicing, it is exactly like a list. But the difference now between the two comes when you try and make changes to the tuple. If you want to replace values, if you want to add items and all that stuff, that is now where the difference comes into place. So let's start with the basic one, my tuple. I want to replace the value in index position 4 with the number 6. Sorry. Change this. With the value 6, I get an error, and it says tuple object does not support item assignment. If I do my tuple, same thing, tuple object has no attribute pop. If I want to do my tuple dot insert index position 3 value 5, same thing, error. Tuple object has no attribute insert. So basically, any action that modifies the tuple is not permitted. Any action that shows something about the tuple is okay. So you can index, you can slice and get different values. And just like for list, let me add one more here before the manipulation. So my tuple, sorry, I want to get the length. So len my tuple. Yeah, so length can return, you can get back the length of your tuple. In this case, we have 9 values in it. But any change you want to make is not permissible. The only way you can make a change is by actually just completely reassigning the tuple to something. So my tuple is equals to, remember, parentheses, 634, 765, 987, and then my tuple. That's the only way you can make a change. You have to reassign the values afresh anytime you want to make a change. You might ask the question, so why would I use it? Say you've got good example, the information that is on your ID card, your name, the ID number, date of birth and all that stuff. And maybe you're using that as something that you use to authenticate entry into a system or whatever. Every single time Eric shows my ID, those values will never change. They'll always be the same. And that way, I want to use a tuple because I don't want some random person coming and change my date of birth and change my ID number or whatever. And so that's the kind of data that you want to put into place in a tuple because you know that it'll never change for the life of whatever project it is you're working on. But a list can change. I can have Eric's information. I can have Catherine's information. I can have Dan's information. So you can have a list of users, a list of Eric, Dan, and Catherine. And then for Eric, you can have a tuple of his information, his birthday, his ID number, his name. So those are the two different use cases between the two, why you would want to choose a tuple over a list. And when we go ahead, you'll see certain examples, like in some of the libraries we'll encounter ahead. There are certain parameters that are read in where you read in as a tuple instead of a list, because those parameters are never supposed to change for whatever it is you're trying to do. But then there are other parameters that can change during the runtime of your code or whatever, and that can be in a list because you can alter them on the fly. So a tuple is for the stuff that you never want to change during the operation of whatever it is you're working on. A list is something that can change during the operation of whatever it is that you're working on. Any questions on tuples? Okay, so we'll now look at the final data structure. There's actually two more. There are sets and the dictionaries. We're not going to touch at all about sets. Whatever links I share on documentation, you can go ahead and read that and find out what they are. So we'll just stop at dictionaries. And that's because for sets, we really don't use them in whatever is coming ahead. But dictionaries, everything else we've discussed so far, we'll use in one way or the other in additional, in future modules that we're going to get into. So the last that I'm going to look at for now are going to be the dictionaries. So a dictionary is data type where the values are stored in pairs, and the pairs, it is in a key value format where you have a key that identifies what a particular value is. And the keys are unique. You cannot have two keys being the same thing. Say, for example, you have your, let's say what? Let's go back to the name example that I'd given earlier, where you have your customers and you say that name, first name, Eric, second name, Gitonga, occupation, engineer, location, Nairobi. So the name, first name, second name, occupation, location, those are keys. The values, Eric, Gitonga, Nairobi, engineer, those are values. So that's what a dictionary is. And so let's come up with my dictionary. And my dictionary, so you've seen tuples are defined by parentheses, as you've seen in the previous example. Lists are recognized and defined by the square brackets. Dictionaries are defined by the curly braces. So that's an empty dictionary. So the curly braces is what defines a dictionary. And if I was to type my dictionary, it should show that it's of type dict dictionary. Then how you go ahead and define the values in a dictionary is you specify. So let me just stick to single. So first name, Eric, second name, location, Nairobi. So let's leave it at that. And then my dictionary. Oh, there you go. So you have here, the key is first name, Eric. Second name, Gitonga. Location, Nairobi. So basically that is what a dictionary is. And each key has to be unique. You cannot repeat, if I was to repeat first name, Simon, and then I run that, you notice that the subsequent key is the one that is picked up. The original key was overwritten by the subsequent key. That's why you cannot have repeated keys in your dictionary. So let's go ahead and change this back. Any questions on that so far?
Yeah, I think so. What did you mean by
so for the
data types are stored as?
Pardon?
The data type, like in dictionaries, the values are stored in pairs.
Yeah, because it is the key value pair. You have your key, which identifies what you're trying to identify, and the value for that specific key. So these are the pairs that it is stored in. It is stored as. Yeah. Any other question? Okay. So accessing items from a dictionary. So it's my dictionary, square brackets, and then the key that you want. So location, it returns Nairobi, or second name, it returns Gitonga. So that's how you identify, that's how you, you get items from your dictionary. It's just the key within square brackets. If you want to change something, say you want to, I've moved to Mombasa and I want to update my records. So it's my dictionary. Then the key that you want to change, location, and then you assign the new value, Mombasa. So now when I call my dictionary, you see it's now changed from Nairobi to Mombasa. Then you want to add a new item. Say I want to add occupation. So my dictionary. So it's just, you use, a second. Yeah, so you just specify whatever key you want. So in this case, occupation, and then the value. Then if I call my dictionary, you see it has now added a new key value pair, occupation engineer. Then you can also update. Just a moment. So there's these two. So this is the first one where you specify the dictionary, the key that you want, and then the value that you want that key to have. You can also add an item. So my dictionary, using the update method, update. And for that, you pass in the pair that you want to update, whatever it is you want to add. So in this case, I want to say, let me do specialization, and then the value electronics. And if I go ahead and call my dictionary. So those are the two ways that you can add value. I mean, you can add items to your dictionary. Either you specify the variable name and the new key that you want and assign a value to that key, or using the update method where you specify a dictionary pair where it is now the new key and the value you want that key to have. And you can also, your values are not limited to just single items. You can actually have a list of items. So let's say I want to do my dictionary. Let's use the update method. And let's say I want to do hobbies. And then my value, I can pass in a list of items. So traveling, reading, photography, and then I go ahead and I say my dictionary. I now have my key. Hobbies returns a list of items. So you're not limited to just single item values. You can actually return a list of items. And if I go ahead and call for that key, my dictionary hobbies, it returns that list. If I do,
Excuse me.
then you can also do very interesting things. So in this case, yes. Yes,
Then,
question?
yeah, I see there are places where you used the square brackets, like when you're changing the location. Yeah, so, and in other places you're using the curly braces. So what is the difference?
If you're changing, so for location here, if you're accessing a key value from a dictionary, you always use the key within square brackets. Curly braces are used if I'm want, like you see here, I'm adding so in cell 250, I'm changing the value of location from Nairobi to Mombasa. So I accessed that location key and I said for that key, assign it to the new value Mombasa, replace Nairobi with Mombasa. Cell 251, I don't have occupation as part of my dictionary, but I'm saying I want to add a new key value pair, and the key is going to be occupation. So if I'm using the key, if I'm using the key to assign that, to generate the new key value pair, it has to be in square brackets. Where I call my dictionary, I call the new key that I want within square brackets, and then I assign the new value of engineer to that. If I'm using the update method, update is a function that is based on the dictionary object. If I'm using it, the parameter that I pass into update has to be in the form of a dictionary key value pair, but with the curly braces. You notice here it's square brackets because I'm calling out this key and then I'm assigning the value. But here, I'm calling out the key value pair as one item, and that has to be within curly braces. Is that clear?
Yeah, thank you.
Okay, welcome.
Eric, just maybe one question. I'm not sure if you've gone through it. So far we've been changing the value that is stored, maybe like through, but is it possible to change the key? Like, let's say hobbies, you change the name to interest.
That's a very good question. Let me just find out. Let me just see. Actually, what we can do. Let us Google and find out together. Python change dictionary keys. Let me see who I want. The name of a key. Yeah, let's go to this. Is there a way to change the key of an entry? Okay, yes. You've seen that? So let's go ahead and test that. So, yeah, so my dictionary is interests, my dictionary hobbies, my dictionary. No, this only assigns, let me go back, where are we? New key, old key. Ah, yes. Then, so you have to assign and then delete. Yeah, so there's
Okay.
no like single way. You have to assign the new key and then you delete the old key. Which again, we might as well just look at this. So delete my dictionary, hobbies, and then my dictionary. Yeah, so that's the way you do it. Okay.
Sawa.
So okay, then so that has introduced how you can modify your dictionary. So there's this delete, where you can delete a specific key. In this case, we've deleted the hobbies key, and we no longer have it in place. Instead, we have the interest that we replaced it with. That's one way of modifying, removing items from the dictionary. Actually, not one way, but let me see. Yes, that's one way of removing items from the dictionary. As soon as my machine stops misbehaving. Yes, yeah, good. So using the delete keyword to remove items, you also have pop item. So if I do my dictionary.pop item, and similar to what we had in lists, so basically what it's done, it has popped the, and this is also something that happens with lists as well that I forgot to mention. When you run it, it just lists what it has removed. It shows what it has removed. If I go ahead and call my dictionary, you'll notice that we no longer have interest in place. We no longer have interest item, and it pops out the last item. And similarly to lists, if you specify something, specific position, I want to guess it will do that. I've never done it, but let me see. Ah, okay. It's not like lists, where you remember for lists, you could specify an index position and it will remove the item in that position. But for dictionaries, all it does is just removes the last item from your dictionary. Any questions on that? And that is it for dictionaries. So is there anything that I've talked about dictionaries or tuples that you'd like me to repeat? If not, that's the end of our session today. I'm not going to keep you that much longer. Next week, when we come back, we shall go into Booleans, which will then now lead us to logical operations and then control structures in Python, where, because all we've been doing now is just, we've done programming where we go from one step to the next. But to make it more interesting and have more useful programs, you need to be able to know, to make decisions that how can I control the flow of my program? If something happens, can I go a different direction with my code, or can I keep the same direction I'm going? And then also repetition, the for loops and the while loops, where if you have statements you're repeatedly using, then you use those ones to automatically run those codes, that set of code for you. And then we'll finish off with functions, where we've seen some of the built-in functions like print, like round to round the number of decimal places, and then also how to define our own functions, so that if we have code that we want to reuse elsewhere, we use these functions to help us do that. I'm going to share this recording once it's ready and uploaded. I'd already sent the notebook, so you can refer to that in case there's anything you need to look back into. And we've done enough that I should be able to assign a quiz to you, which I'm going to do. I'll set it based on the material that we have covered so far. And I'll also get like maybe some practice exercises that you can use, where you can do programming exercises. Like we had said last week, practice is what is going to help a lot of this material get assimilated in your brain and all that stuff. So the more practices that you can do, the better for you. So I'll also send links to some sites that you can go to where you can have like Python programming exercises and just try them out. As always, if you have any issues with the material, with the course or whatever, feel free to reach out to any of us, myself, Fiona, Alice, Ernest, or Mary, and we should be able to assist you. If you need additional sessions during the week, if there's something that is very not clear and you would like to schedule, like maybe a 10-20 minutes call, we can do that as well. Any issues, any comments as we come to a close?
Okay, Eric.
Yes.
The method pop, I've seen when you're using a dictionary, it's pop item, and when it's on a list, it's pop.
Yes.
Okay, okay.
Yes. A lot of these objects will have like methods and functions, methods specific to them. And so you might find something that might look similar, but then is different and behaves differently depending on what object it's acting on.
Okay.
Okay. If nothing else, then I wish you all a wonderful weekend, and we shall meet up next week.
Thank you.
Thank
Bye.
you.
Thanks, Eric.